Hey guys, a very good morning to you. Science Steve coming to you live this morning. A Wednesday, middle of the week, it is hump day. We're coming to you live via Facebook or YouTube or however you guys are tuning in. We're doing it live from Street Science Studios. Now today is really special because I'm not going to be the one running our science lesson today. You're going to be joined by a dead set legend. A lot of you guys, if you're in Southeast Queensland, you probably know this bloke because I reckon he might have come to your school. It is Tim O'Shea, or you guys probably know him as Timo. He's one of the scientists, one of our science communicators that work here at Street Science. So he's going to be exploring, well, by the looks of it, forces and flight. He's got lots of gadgets. I can see flammables. I can see a lighter over there. I can see rockets. I can see a Bernoulli's bag. I can see little items from our Street Science shop as well. So, in fact, when I look at his run sheet here, whew, you guys are in for an absolute treat. So, strap yourselves in. Mums and dads, some instructions for you. Go put the kettle on, make yourself a cup of tea, and go and get some work done, all right? Because we're going to take the kids off your hands for a little while. Kids, if you're locked down and you haven't been sent to school this week, totally cool. Relax, sit on the couch, kick back in your chair. If you're a bit of a keyboard warrior and you want to drop any questions or any comments into the Facebook comments section, you are more than welcome to. Make sure it's really positive stuff. At the end of today's session, Timo and I are going to hang around and we're going to answer some questions for you guys because Tim's brain is massive. He's incredible. And he said, hey, Science Steve, can I hang around at the end and answer some questions? Because so many of you yesterday didn't want us to leave. So many comments said, please hang around and do more science. So today we're going to do it for you. So we'll hang around at the end and do a little bit of Q&A and we'll tell you how that works later. But feel free to let us know where you are tuning in from in the comments section because I love seeing how far and wide these broadcasts are getting to for you guys. If you're at a school, so if you're in a school in Southeast Queensland, maybe somewhere else around the country, let us know what grades tuning in, how many of you there are in that classroom or the auditorium, wherever you guys are coming from. We might even do some shout outs. I think we did half a dozen schools yesterday. There would have been about 50 schools tuning in, so sorry if we didn't shout out to you in particular, but we love you for tuning in, so thank you teachers. Hope you've learned a bit today, and above all else, I hope you have a heap of fun learning science. All right, I'm going to get out of here because it's not my lesson today. I'm going to head out this way, out of the studio, which means my man Timo is going to appear somewhere from this direction. Enjoy yourselves, kick back, relax. Parents, get out of here, go get some work done. If you want to follow along with Timo, there is an activity that he's going to do with you that you guys can copy at home. You will need an adult to do it, so you won't copy it while he's doing it, but later on today, or maybe over the Easter weekend, you guys can do this particular activity. The downloads are going to be up on the Street Science website in PDF form, so you can just hit print for mum and dad to do it with you a little bit later on. It's fully sick. All right, I better get out of here because Timo's chomping at the bit. Enjoy the session. I might even see you a little bit later when Timo's setting off some rockets. Who knows? All right, Science Steve signing out. See you guys later. Timo, mate, they're all yours.
Alright, hello everyone. So, as Science Steve mentioned, you guys are all at home. A lot of you guys at home. I've already seen a few people popping some comments, so I'll give some shout outs already. I think I saw Logan Reserve State School and Palmwood State School, they're tuning in. So good morning to you guys, good morning to parents as well. Now, Science Steve mentioned earlier that you parents, you might want to go and grab a cup of tea, but be warned, you will want to have a close watch over your tea bags this morning because your kids might be coming for them later on. We'll look into that a little bit later. Now, as Science Steve mentioned, today we're going to be looking at forces and flight. Now, there's a very clever scientist from a long time ago, some of you guys might have heard of him, called Sir Isaac Newton, and he came up with a lot of different ideas about forces, okay? Now his first law, okay, his first law of motion, that is how things move, was this idea that an object, so like my cup here, that's at rest, will stay at rest. It means it'll stop moving. It won't move unless we either push it or we pull it, okay? We call that inertia. It stays at rest, all right? Now, I want to show you guys a little trick that you can do to demonstrate inertia. What you're going to need, this is something that you can do at home. You need a little cup, you need a coin. I've got a coin here as well, and a card. Now, I've got a really big card that I stole off Science Steve's desk, but you could use a playing card, might be a little bit easier. What I'm going to do is I'm going to switch my camera over, and we're going to place this card on top of my cup, and then I'm going to pop the coin over the top, and then I'm going to try and flick this card out. And I want you to see what happens to the coin. Let's give this a go. All right, let's flick over to the camera. Here we go. So you can't see it, but I've got my little coin. It is sitting on top of my card here, okay? So let's pop that on, and I'm going to try and get my finger and flick it out, and have a look at that. Our coin has stayed in the cup, all right? Now, the reason that our coin has stayed in the cup is I actually haven't applied any force to it in this direction. I applied all of the force to that little card that was sitting there, and as a result, my coin stayed at rest. Well, it stayed at rest for a little bit until gravity pulled it all the way down and into my cup. Okay, so that's a little trick that you guys can explore at home with your coins. All right, now speaking of forces, so we want to push and pull things. There's a lot of different ways that we can do that. Now, I've got a little bit of a problem, everyone. Okay, now, the other day, I was playing some backyard cricket. If you like playing backyard cricket, make sure you chuck in a comment saying, I love playing backyard cricket. And I can see a lot of people like playing backyard cricket. Okay, now, I was playing cricket in the backyard, and the ball got bowled to me. And I actually hit one of the best shots I've ever hit. The ball was smashed, and it went sailing and sailing and sailing, and then went clonk into my mother's favourite vase. Okay, now this is a little bit of a problem, everyone, because, well, this is my mother's favourite vase, and this is my favourite cricket ball, and they are stuck. Okay, now I tried to apply one type of force to it. I tried to pull it apart, but I didn't really have any luck with it. Okay, so I need another way to do this. Now, to do this, what I thought I'd do is I thought I'd bring along something that's involves a little bit of fire. Okay, something that can undergo a combustion reaction, something a little bit like my butane here. Now, those in year 6, if they've had street science incursions come out, some street science shows, they'd know that butane is an example of a fossil fuel. It's a non-renewable resource, which means that, well, once we've used it up, we can't really get any more, because we'd have to wait millions and millions of years for all of the plants and animals that are around now to die and get buried and eventually compacted into this butane. So we have to be careful with the way we use it, all right? But one good thing about this butane as a fossil fuel is that it is quite flammable, okay? So if we apply some of this butane to fire, as you can see, it combines with all of the oxygen in the air and generates a bit of fire. Now, I was thinking to get my ball out of my mother's favourite vase, what I could do is I could start this combustion reaction inside the flask. Okay, inside my mother's favourite vase. And hopefully that would build up enough pressure to push my ball out, to move it out. Let's give this a go. Okay, so I'm going to measure out a little bit of butane into my syringe. We're going to pop it inside my mother's favourite vase. And I want you all at home to give me a big countdown, okay? Here we go, let's count it down. In 3, 2, 1... Whoa! There goes the ball! And that applied a really good force to set my ball in motion. Okay? Now, speaking of pushing and pulling forces, I also have another little bit of a problem. And that problem is that I'm really, really clumsy. When I have my cup here, what happens is, well, sometimes I forget that there's water in the cup and that gravity exists that's pulling everything down to the ground, and I pour it over and that water spills out, okay? So I thought I'd come up with a bit of a solution, okay, to my problem. I'm going to get a little bit of blue water here. I've just added a little bit of food dye into it. And then I'm going to pop this water into my cup. Let's fill it all the way up. Now, to overcome my, I guess, clumsiness problem, what I was thinking I could do is I was thinking I could use a card to counteract gravity. Okay, so I'm going to grab my little card here. And what I'm going to do is I'm going to pop this card over the top of my cup. And that way, when I spill it, like the clumsy scientist that I am, I can hold that water in the cup using my hand. So we've still got gravity, which is going to be pulling down on my cup. And my hand is pushing up on it. Oh, what's going on here? The cup's still in place. I thought, wow. Let's try that again. We're going to take some of this off. I'm going to scoop up a little bit more water. Now, there's something really interesting going on here involving something that we call pressure. Now, pressure involves forces as well, but it's how concentrated the forces are in a way. So pressure is force divided by the area, okay? Now, I could apply a force with my hand up against, say, my chest here. If I push it with my hand, I'm applying a pretty strong force, but that's spread out over quite a large area. However, if I reduce the area by getting my finger and applying the same force, oh, it hurts a little bit more. You might be able to feel that as well if you try it at home. If I was to get something that had an even smaller area, say something like a toothpick, and I applied the same force, well, that pressure would be a lot higher, okay? And you'd probably be able to feel that a lot more, all right? Now, what's going on here? When I pop my cup upside down, you can probably see a little bit of water leaked out, okay? And as a result, we actually have less pressure inside the cup than there is outside. So then when I took my hand away from the cup, ooh, there it goes, we've spilled it down. Oh, obviously not enough pressure. Let's try it again. We're going to spill it upside down. And then when I take my hand, it's obviously not working anymore, and I've got everything wet in here, okay? So the idea is when I took my hand away from the cup, let's pretend there was water in there, then the pressure inside my cup was lower, and the higher pressure air all around us was pushing up, applying a force to my card here and holding it in place. Now, everyone, I've got everything a little bit wet in here. Science Steve's not going to be happy with me at all. So let's just put some of that water away and let's explore some other forces. Because I mentioned a little bit earlier that there was one way that you guys could do an experiment at home involving some of your parents' tea. Well, I didn't mention it, but I alluded to it a little bit, okay? So if your parents have some tea at home, or we've got some shout outs, I'll just do some shout outs before we move on to the next little experiment. So we've got all the homeschoolers at home. Welcome, guys. Hope you're having an awesome time at home with everyone else. Rochdale State School. I know I've been out there a couple of times, and one of my fellow street scientists, Dr. Shaz, I'm sure a lot of you guys know Dr. Shaz. She is an alumni of Rochdale State School. She used to go there when she was a junior street scientist as well. So maybe we might get another Rochdale State School student to become a street scientist in the future as well. Virginia State School, just down the road from us. Hey guys, how are you going? Our Lady of Fatima as well. I know I've headed out there a couple of times as well. I hope you guys are doing well at home. And McDowell State School, likewise. I hope you guys are having a fantastic time. Now, speaking of having a fantastic time, I'm having a fantastic time at the moment. What we're going to try and do is I want you guys to very kindly ask your parents if you can borrow a little bit of tea, okay? I've got some tea here. I've actually stolen it from Science Steve's little stash. He doesn't know about this. Next minute, he could be coming in here and stealing it back off me, because what we're going to do is we're going to make some Teabag Rockets, okay? The way we do that, we just need to grab some tea. I've got some tea here. We're going to cut the top bit open. Let's try this out. cut this off. And we're not going to need any of the tea inside here, so I'm just going to tip that. Let's just pop that away inside my cup here. And simply what we need to do is we're just going to open it up here. I'm going to pop it down on my plate. We're going to switch the camera angle over in a second. Here we go. Let's make sure you guys can see. All right, so I've got our tea bag sitting on our plate here. What I'm going to do is I'm going to get my lighter here. I'm going to light up my tea bag. Now, if you're trying this at home, this is probably an experiment that you might need your parents' help with, okay? Because we're going to be using a lighter or some flames. Let's light this up and let's see what happens. Okay, so we've lit it up on that side, we've lit it up on this side. It's burning down as you might expect. And then, let's see what's happened. It has flown all the way up into the air. Wow. Let's try it one more time. This experiment always amazes me. We're going to go back to my camera down here. I'm going to get another tea bag. So let's do this a little bit closer so you guys can see what's happening. Actually, have a look. This has just landed back down. So let's do this nice and close so you guys can see. So what I just do is we're going to cut the top off. Now this is something that you can do at home. Cut the top off. Then tip the rest of that tea out. I can just stay on the bag here. Perfect. Then what we're going to do is make sure it's nice and open. Get all that tea out. Oh, I've made more of a mess. Here we go. And just balance it nice and delicately on your plate. Ugh. There we go. And then ask your parents, grab the lighter, light it all the way around, and let's watch it fly again. Here we go. 3, 2, 1. Oh, off it goes. And let's see if we can see this one land. Oh no, this one's landed behind the camera. Okay, so that's a cool little experiment that you guys can do with your tea bags at home. Okay. Now, speaking of things flying up, I was actually out at a school nearby last week. Okay, I was out at Sherwood State School. Shout out to anyone at Sherwood State School, and we were doing a pretty cool experiment. Okay, all those students in year 4, we were launching some rockets. Okay, so all the students, they got to build a little rocket just like the one that I've got here. Let's have a close look at it. So all the students, they got to build a little rocket, write the name on it, add some fins to make our rocket aerodynamic, and give it a bit of decoration as well. Now with this rocket, let's just pop back. What they do at the end, what these Sherwood State School students got to do in this rockets workshop that they got to do was they pop some water inside their rocket. Let me get some water. Where is it? Down here. Still got my bucket. 1, 2 squirts of water. And then I handed out all of these Sherwood State School students a little bit of rocket fuel. Okay, I've got some rocket fuel hiding behind here. Okay, they popped their rocket fuel in the lid, and then let's go to your close-up vision. They went to, I'll move my plate out of the road. They went to click on that lid, and that rocket fuel started to combine with the water, give it a little shake, and it started to generate some bubbles, increasing the pressure inside the rocket, okay? Increasing it so much that eventually, well, the lid couldn't hold on anymore, and the rocket decided to fly up into the air. It was pushed up into the air because that gas pushed down on the lid and pushed it back, okay? That always scares me so much. I think I'm going to need to take a deep breath. All right, let's flick back. Now, you guys can have some fun launching rockets. You might get to have a rockets workshop if you're in an OSH. We come out and do some outside school hours care as well. Or if you're in year 2 and year 4 and you're learning about forces, and you get asked your teacher very nicely, and we might come out and launch some rockets with you, okay? All right, let's do some more shout outs while we're here. So we've got some students tuning in from St. Pius at Banyo. I've been to that school before, hung out with some of the year 2s, which was awesome last year. Aspley State School, Oxley State School, Ipswich Central State School, Daisy Hill State School, and Jubilee and Bald Hills State School. So many schools are tuning in today. All right. Now what we're going to do, because I know a lot of you guys enjoyed that rocket launch so much, I thought we should do it one more time, but this time we're going to have a look at it from a different angle, okay? So once again, we're going to get some rocket, all right? Now, my lid is a little bit wet, and this chemical reaction that sets off our rocket actually involves the water, okay, combining with the rocket fuel. So I have to make sure that I dry my lid, as those students at Sherwood State School would know, before I add the rocket fuel, because otherwise my rocket might not launch, okay? That chemical reaction will start a little bit early, all right? Let's pop a little bit more water into my rocket. There we go, 1, 2 squirts of water. We're going to grab a little bit more rocket fuel. We're going to click on that lid and let's watch it launch one more time, okay? Hopefully this time it doesn't scare me as much. All right, I'll give it a little shake. And as I can see, it's building up the pressure inside my rocket. There's lots of carbon dioxide gas being formed. It's pushing all against the rocket, and eventually it's going to push so hard that that lid can't stay on, and it'll push it down into the ground, causing the rocket to be pushed back up into the air. Now I'm seeing lots and lots of bubbles being formed. I'm actually getting a little bit worried, so I'm going to hide underneath my table. Has it gone yet, everyone? Has it gone yet? Oh, it's gone off! Wow, there goes my rocket again. Okay, so I've had a lot of fun launching rockets, and I get to do that a lot when I get to come out to some of your schools and do it with the year 2 and year 4 students. But if you guys would like to launch rockets at home, we've also got something for you. We've got some of these liquid Fizz Rockets. All right, now we've got a few more shout outs. What is the rocket fuel you use? Okay, the rocket fuel we use is something that we make here at Street Science, a very special rocket fuel. It uses some household ingredients, citric acid, bicarb soda, and corn flour, okay, combines them together. When the water combines with the citric acid and bicarb, that starts that chemical reaction which produces the gas which launches our rocket fuel. If you guys have us out for a rocket's birthday party, OSH or school show, we'll also give you a little card which will tell you how you can make your own rocket fuel. And I believe, I'm not sure about this, I'll have to confirm this with Science Steve later on, if you jump onto the Street Science website, there should be instructions on how you can make your own rocket fuel. I'm getting the big thumbs up, which is fantastic. All right. A few quick shout outs as well. St. Dimpner's, Jubilee Primary, St. William's Primary, and Burpengary State School as well. Hope you guys are having an awesome time. Okay. Now, what I thought we could do, we're having so much fun launching rockets. Let's launch one of my Fizz Rockets. So if you guys are really itching to launch a rocket today, you can't wait until you have Street Science in for a rockets workshop. You can actually jump onto our online shop, and we've got these Fizz Rockets, okay? They'll come in a little box like this. But once you open it up, you've got these cool little rockets. Let me flick the camera over so you guys can see this nice and closely. So you have a little rocket, just like this, and a little container at the bottom. Okay, so this works a little bit similar to our rockets, but we use some slightly different materials, okay? Well, you could use the rocket fuel that we make, or you can use some other household materials that you've probably got at home, okay? I'm going to flick this back. Now, the household materials that you'll need for this is a little bit of bicarb soda and a little bit of vinegar, okay? I've got some vinegar down here, all right? Now, what we do is this bicarb soda, it goes in the base of our little rocket here, okay? So there's a little bit of a hole here where you can pop it in, and I'm just going to get a scoop out. We'll pop a little bit of bicarb soda in there, and then the vinegar is going to go into our rocket tube. Now this is going to involve a very similar chemical reaction to our rocket that I launched before, okay? But this time the chemical reaction is involving two different things, okay? So bicarb and vinegar. The chemical reaction still produces carbon dioxide as the gas that's produced, and it should still hopefully launch my rockets. Now I'm going to let you guys in on something. I've never actually launched one of these rockets before, so I better read the instructions, make sure that I'm doing it right, okay? Powered by vinegar and baking soda, cool, I've got the right things. Let's pour a little bit of vinegar in here. Whoop, that's probably a bit too much. Let's pour a little bit back. Alright, I'm really making a mess today. Okay, let's pop our vinegar away. And what I'm going to do is we're going to try and clip on the lid of this rocket to the top. I'm going to place it down and we're going to see if it launches again. Okay, watching closely. Let's click this on. I'm going to place it down and whoa! There goes our rocket. Alright. Now I've still got a lot of bicarb soda in there, so I probably didn't need as much of that bicarb soda, but that rocket still launched up. Did I break the roof? Not quite. Okay, fabulous. I haven't broken the roof here. Alright, so if you guys jump onto the Street Science store, you can grab one of these. Grab some vinegar, bicarb, you've probably already got that home, and you can launch your own rockets. What a great way to spend your Easter, okay? Launching some awesome rockets. Now, when I was speaking to Science Steve earlier, he mentioned that if anyone does want to jump on and buy some of these rockets, then he's going to chuck in another little science treat for you guys. That science treat is one of these little whirlpool things, okay? They don't look that amazing. They're just these little connector things that I've got here. But what they do is they allow you to connect two soft drink bottles, okay? You screw them on. I've already screwed this one on. And, well, it allows you to pass liquids or pass fluids from one bottle to the other. Now, I've got a little bit of a problem, okay? Because I want to get as much of this liquid, much of my water here, into the other bottle as quickly as possible. But when I turn it over, this happens really, really slowly. Because there's something in this bottle that has to get up into this bottle as well. If anyone in the comments wants to chuck in what they think that substance is that's sitting inside this bottle and is trying to make its way up into this bottle, you can see some little bubbles forming up here. Just chuck it down in the comments if you think you know what that fluid is. Alright, we'll wait for a few different responses, and we're going to try and use that knowledge to come up with a better way of getting all of this water from this bottle into this bottle, because at the moment it's happening really, really slowly. Okay, I'll give you guys a bit of a clue. This material is a gas. Okay, I already see that some people have gotten it. Actually, I'm just looking through the comments. Everyone is saying air, and you guys that have said air, you are absolutely right. Okay, so that air is trying to pass up into my bottle, okay, but it's happening really, really slowly. Okay, now what we can do with this is we can give it a little bit of a shake, okay, because I want to start to get this air moving up a little bit more quickly. Now, I've heard that if you give this a really good shake, you can make a little tornado inside the bottle. Let me bring this up close to the camera. You might be able to see I've got a little tornado. Oh no, that tornado stopped. Let's give it another bit of a shake. And we've got a little tornado inside the water. That's allowing the air to move its way up really, really quickly so that water can fill down into my other bottle really quickly as well, okay? Because you might not be aware of this, but air, okay, is actually a fluid as well. It can flow, okay? So if you guys jump on and you grab one of the Fizz Rockets, you can get one of these as well. Science Steve will chuck in one of those too. So lots of experiments that you guys can do over the Easter break. All right, so someone said, Tim, your TV show is the best. Oh, I wish I had my own TV show. That's great. Thank you very much. Shout out. So I've got a few people in Sandgate, Olivia and Tara in Sandgate. I went and took my bike for a little bit of a ride out at Sandgate this morning, which was fantastic. We've got Mount Carmel, Corporoo, Caboolture High as well, Padua College. I went for a run past there yesterday afternoon as well. And a big shout out to our mates at St Oliver Plunkett Cannon Hill School. I know we've been there a lot as well. Alright, now speaking of forces and stuff that we can explore with forces, I've got a little bit of a bag here because I want to explore something. Just one moment, guys. I'm just going to get the camera to switch back on for me. Here we go. You probably can't see me. Alright, I'm back, okay, because I've got this mystical bag and I want to test how much force I can release from my mouth, okay. Let's get this bag out. Ah, there it is. And I want to see how much of this bag I can fill with one breath of air, okay. This is what respiratory scientists, they would call this my vital capacity, okay. So I'm going to pop this onto my classroom kit here. Pop some things out of the way. This classroom kit can hold it up for me. There we go. And I want to see how much air I can fill this bag with. Okay, let's go. That's alright. That's alright for some pretty small lungs here. But what we can do as well is we can actually apply a little bit more air into my flask, into my bag, okay? If I hold this bag out, if I hold it again, and this time I blow a little bit differently, I want you to watch what happens, okay? Let's hold it out. I'm going to get this classroom to hold it a little bit more, so here we go. I'm going to blow a little bit differently, and I want you guys to watch how much air we can get in. Alright, here we go. Oh, look at that! Do you guys think I have that much air inside these tiny lungs? No, of course I don't, okay? What I did here was I used a trick called Bernoulli's principle. Now, earlier on we were talking a little bit about pressure, and Bernoulli's principle involves pressure, and it also allows things to fly, okay? So when I blew from outside the bag here, I generated a fast-moving stream of air, okay? And that fast-moving stream of air has what we call low pressure. As a result, the higher pressure air all around this fast-moving stream of air pushed its way into the bag, and so I was able to fill the bag with a lot of the air around me. Okay, so pretty cool stuff there. Now, Bernoulli's principle allows us to do a few pretty cool things. It helps aeroplanes to fly because the air moving over the top of the wings moves a lot faster, so it has lower pressure, and the air below the wings has higher pressure, which helps push the plane up and generate lift. But I've got a feeling it might be able to help me make some other things fly, okay? Now, one thing I was thinking of trying to make fly at a birthday party that I'm supposed to be going to this weekend, not sure if we'll be able to go, but we'll see, is a beach ball, okay? I was thinking that if I could generate a fast-moving stream of air with my breath, I might be able to generate a region of low enough pressure around this beach ball to make it levitate in the air. Let's give that a go. Okay, here we go. 3, 2, 1. It's not working for me. Now, I was actually watching Harry Potter the other day. Who's seen Harry Potter? Some of you guys might have seen Harry Potter before. You might know that there's a spell that they use to make things levitate. If you know the name of that spell that they use in Harry Potter to make things like my beach ball levitate, can you pop it in the comments and we'll see what it is, because I've actually forgotten, okay? What we want to do is I want to try and use that spell, and maybe that spell might help us make this beach ball levitate. Let's see if any of those spells are coming through. I'll give you guys a clue. We don't have any of them coming through. It starts with a W. It is Wingardium. Oh, we've got one there! Wingardium Leviosa. Well done to Rebecca. I think it was Rebecca that came through with Wingardium Leviosa. Alright, Wingardium Leviosa. Okay, we're going to try that one more time. Here we go. I want you guys to all call out Wingardium Leviosa. Okay, here we go. 3, 2, 1. Ugh. Still doesn't work. That's a bit of a problem, okay? So what we might do is I know I'm missing something. In Harry Potter, they have a wand as well as that spell. Now, I don't have a magic wand, but I do have a science wand, okay? Now, this science wand, it can be a little bit noisy, okay? It does make a little bit of noise, but I feel like we might be able to make our beach ball levitate as well. Here we go. All right, let's test it out. I want you guys at home to yell out Wingardium Leviosa in 3, 2, 1. Wingardium Leviosa! Whoa, I've gone a little bit too hard. Whoa! Let's see if I can move this over a little bit. Let me bring it down so you guys can see it. Oh, and our beach ball is levitating. Have a look at that. Now, as you guys have probably seen, my magic wand is not actually a magic wand. This is a leaf blower. It was generating a really fast-moving stream of air, and that fast-moving stream of air had low pressure. So all of the high-pressure air around could push against that ball and hold it into place. If you guys have a beach ball and a leaf blower at home, you can test out this experiment, but this also works if you've got a hairdryer and a ping pong ball. You guys might be able to spend some time at home today using your mother's hairdryer and getting a little table tennis ball or ping pong ball and making it levitate. Make sure you send through any videos if you guys have got some videos of some junior scientists levitating some ping pong balls or beach balls. I'd love to see them. Alright. Now, speaking of forces and moving things, so far we've been moving things a lot with the air. Okay. We've got the air from my breath. We know that that can move things. I can move the air particles into the bag, okay? I can also push objects around from a distance, okay? I can move my cup ever so slightly. But as you guys have seen, the breath from my air, well, it ain't great. I can't push that much air out of my lungs. So I thought I'd bring along something today that can push a little bit more air, okay? My air Zuka, okay? This air Zuka, if we pull it back like this, I've got a little bit of elastic here, if I pull it back and then I push, it pushes air out. Let's see if I can make this cup move. Ready? Whoa, see how much that cup moved. And it's gone, okay? Now, these forces that I've been applying with the air, they're actually all examples of what we call contact forces, because those little air particles, they're inside my air Zuka, and they're being pushed, went straight towards you all at home, out, and those little air particles are floating through the air, and they're crashing into things, they're contacting them. But you guys can't really see that, okay? But later on, we might be able to have a little look at what those air particles would look like, okay? Let's just flick. We might be able to have a look at that a little bit later on, okay? Now, speaking of moving the air, there's another little toy that you guys can play with at home, okay? This is something that probably is also on the Street Science website, might even be in some other kits that you can use. These are our rocket balloons, okay? Let's show you how the rocket balloon works, all right? So I've got a pump here. I'm going to blow up my rocket balloon, and I ask for some predictions from everyone at home, okay? I've got my rocket balloon up here like this. And what I'm going to do is I'm going to let go, okay? And let's see which way the air goes. So the air is going to go that way. And I want you to all think about what way my rocket is going to go. So chuck it in the comments if you think my rocket is going to go towards the classroom kit or towards my Whirlpool bottles, okay? Make your predictions, all right? I'll let some predictions roll through. Will my rocket go towards the classroom kit, or my Whirlpool bottles? All right. So I'm sure you guys will be making predictions. I know you're on a little bit of a delay, so those predictions are going to roll through. Let's test it out. Here we go. 3, 2, 1. Whoa! There goes the rocket balloon. It went flying out in the direction of my classroom kit. Okay, all you guys are exactly right. I see classroom kits flooding through the comments. If you got that right, give yourself a massive round of applause at home, or give yourself a pat on the back. Okay, fabulous. All right, we've got a couple of more shout outs. So we've got Addie and Nico in Brisbane, Lila in Brackenridge, and Burpengary State School again. So I must have a few people tuning in from Burpengary State School, which is fantastic. All right, so we've looked at a lot of different forces today, and all of the forces that we've seen so far involve pushing and pulling things by making direct contact with them, okay? But there's another little thing that we can do. We can apply forces from a distance, okay? I've got another little object on my table here. I'm going to switch the camera over so you guys can have a nice close look at it. All right, let's just move it around so you can see it. Now this object, it's at rest, okay? And so far we've seen that to move objects, we often need to push and pull them, okay? But with this object, it has another interesting property. If I get another object that looks a little bit like it, and I bring it close, it gets pulled up from a distance, okay? Now, I'm going to leave it over to you guys at home. If anyone thinks they know what these two objects are, chuck it in the comments, okay? And we'll figure out how these objects are applying forces at a distance, okay? Now, while you guys are getting in on the comments and doing that, I want to show you one last experiment that you can perform at home, okay? Now, for this experiment, it actually involves quite a technical piece of scientific equipment, okay? One that you might not have access to, okay? You might need to jump on the Street Science store to get it as well, all right? Because this piece of scientific equipment is a piece of paper. Okay, I'm just joking. You guys have probably got that. You don't need a biased piece of paper from the Street Science store. You guys have probably got that at home, okay? Because what you can do with this piece of paper is you can hold it up against your hand and it will stay attached to your hand. Are you ready? Watch this. Hang on. It was supposed to stay attached to my hand. What's going on? All right. Oh, hang on. I've got some comments coming through here. Everyone's saying magnets, and you are exactly right. Using the magnetic force, a force from a distance that was pulling my magnets together. Exactly right. Give yourself a pat on the back if you got that one correct. All right. So we've got my piece of paper, and it was supposed to stay against my hand. However, to stay against my hand, I need to make it move around, okay? If I keep moving it around, this piece of paper will stay up against my hand, because remember we talked about all those invisible things all around us, those air particles, they're pushing against the paper and holding it against my hand. What you guys can do at home, I'd love to see some videos of this as well, is if you've got a brother or sister or even your parents, you can walk up to them, you can hold your paper and walk towards them, and then they can high five you and you can trade over the piece of paper, okay? I want to see some people doing it at home. It's not very good for me here because I'm here by myself in the Street Science studio, but I want to see some people at home, some videos later on of some of you guys getting the piece of paper, walking along and high-fiving each other and then moving past, okay? Using that force of the air to hold the paper up against your hand, okay? Now, we're almost out of time. I think I've pretty much run out of experiments, except I just remembered that the other day when I was looking at some of the comments yesterday, I saw someone say to Science Steve, how did you make that cloud? Okay, now clouds, they're not fully related to forces and flying, but if you do fly in an aeroplane, you will probably go through some clouds, and the clouds might make it a little bit bumpy, give you a little bit of turbulence, okay? So I thought that's enough of a link for me to chuck in and show you guys how you can make your own clouds. Because the cloud Science Steve made yesterday is a cloud involving a substance called liquid nitrogen, which is super cool. It is minus 196 degrees Celsius, and it's not really something that you can get your hands on at home. But the cloud that I'm going to show you how to make is one that you can use with household materials, okay? This cloud you can make at home. All you're going to need is a old water bottle like this. You'll need a little bit of methylated spirits, or you can use water. I'll explain why I use methylated spirits in a little bit. We're going to pour a little bit of this methylated spirits into the bottle. There we go. And then the last thing you're going to need is a pump, okay? Just a little hand pump and a stopper in it, okay? That makes a nice seal. Because what I'm going to do, I'm going to flick my little thing, get my pump open. Here we go. Let's just roll that down. And then I'm going to increase the pressure. I'm going to push some more air inside my flask here. Remember earlier we were talking about how pressure is how much pushing there is of something in a certain area. Now we're going to keep the area inside my bottle the same, but I'm going to push some more air in. And when we increase the pressure inside here, well, that is going to cause all of that methylated spirits, all those particles to start rubbing together, okay? It's a bit like when you guys rub your hands together. If you rub your hands together at home, you might notice that they start to get really, really hot. So we're generating friction with the particles inside here, and eventually that pressure can become so high that if I let it go, ta-da, you will have made your own cloud, okay? But then, if you pump it again, that pressure is going to be a little bit higher. It'll go clear. And then you let go, the pressure is lowered, and we get another cloud, okay? Because as soon as we lower that pressure, all of those particles that have evaporated, they've gone into the air, they cool down and condense and freeze into tiny little bits of methylated spirits, okay? And then that causes the cloud to be formed, okay? Now it's a bit like, some of you guys might have watched the weather report before, and on the weather report you see these little charts and they have little circles with a H and a L. Now those H's mean there's high pressure, and when we have high pressure, it's a bit like my bottle here, we generally get really clear days, but then when we have a low pressure system coming through, we get cloudy and rainy days. Okay, so that's a little bit of how this relates to pressure. Now guys, I reckon I have used all of the experiments that I've got here, but I did promise one thing a little bit earlier, and that one thing was to show you guys what the air looked like out of my air Zuka. Okay, so what I'm going to do, I'm going to pop some of these materials over to the side, and I'm going to get out my air Zuka. Here we go. And what I'm going to do is I'm going to get something that will hopefully make the air visible. So I'm just ducking over to the side for a second. Let's have a look at what it looks like. Let's go really slowly. Whoa, did you guys see that? These are these little smoke rings. I'm going to shoot one right towards the camera. All right, let's try that one more time. Here we go. So I've got my smoke machine over here. Whoa. Whoa. Did you see that? Let's go right for the camera. Whoa. Whoa. That was pretty awesome. Okay. So guys, remember, Science Steve has got some pretty cool deals for you here today. It's getting really, really smoky in here, okay? We've got some stuff at the shop. You've got our Fizz Rockets. If you guys jump on, grab one of those Fizz Rockets. All you need is the bicarb and a bit of vinegar at home. What type I've got a question already rolling through. What type of vinegar did you use for the CO2 rocket? Any vinegar should work that you get at a grocery store. I just use some black and gold vinegar that we use here at Street Science, okay? But any vinegar that you get from a grocery shop should work. So remember, if you guys jump on and grab one of these, you can have a go at making some tornadoes. Remember, giving these a really good shake and allowing that air, which is a fluid, to pass from one bottle to the other, okay? So you guys can explore that if you jump on and grab one of those Fizz Rockets. All right, guys, now I've pretty much run out of time for my experiments, but Science Steve did say at the start, if you want to ask some questions, now is a really good time to ask some questions. So I've got some questions already coming up. We've answered the vinegar one. We've got another question. How did the air get into the leaf blower? That's actually a fantastic question. Do we know who that came through from? No? Sweet. Okay, so I've got a great question. How did the air get into the leaf blower? Okay, now inside these leaf blowers, I'm not 100% sure, but I think there'd be these little spinny turbines, okay? I've actually got something else floating around on my table. It might have fallen down on the floor. One of my helicopter propellers. I might just get Science Steve, if he's there, to duck out to the shop and grab one of my helicopter propellers, because this is going to be a really great way to explain how the air gets inside my leaf blower. Okay, now Science Steve is just ducking over. He's grabbing one of those. I think they're right up on the top shelf, Science Steve. Oh, right. So Science Steve is jumping into our shop. They're right up on the top shelf. He's going to pass me one of these. Awesome. Thank you, Science Steve. And this is going to be a great way to explain how our how our leaf blower gets the air in. Okay. Now our leaf blower, it's probably going to have a propeller inside it, a bit like my helicopter propeller here. Now on this propeller, I'm just going to move you guys over to my other camera here. You can see that they've got these little blades. Now these little blades, when this propeller spins around, it pushes the air, okay? So it gets the air from around it and pushes it in one direction, all right? Let me show you how this thing works, okay? If I push it up, my propeller goes for a little bit of a fly, okay? Let's try that one more time. I'll do it a bit more speedily. Now when I push that up, the shape of this helicopter propeller allows it to spin around really, really quickly, okay? And that allows it to fly up into the air, all right? Let's try that one more time. I'm going to push it a little bit faster. Oh, and it's gone for a fly. It's almost flown outside the door, okay? So that's pretty similar to what happens inside that leaf blower, okay? It's spinning around really, really quickly, and it's getting the air from outside, and it's pushing it in one direction. And then it gets funneled through that leaf blower, and it generates a fast-moving stream of air, okay? Now, if you reckon these little things are pretty cool, I think that you can get them on the Street Science shop as well, okay? So you might want to jump on and grab one of those as well. All right, we've got some other questions rolling on through. How did why does vinegar and bicarb react like that? That's a good question. So vinegar is what we call an acid, okay? You guys might have seen Science Steve yesterday on the virtual broadcast using an acid, and it changed the colour of our pH indicator. So our vinegar is an acid. The bicarb soda is a base, which is the opposite of an acid, okay? It changes the colour of the pH, or the colour of the pH indicator, to a very different colour, okay? So they're sort of opposites, and when they react, they do what we call a neutralization reaction. They sort of come to be neutral, but this process, because it involves bicarb, releases carbon dioxide gas in the process, and that's what causes my rocket to fly on up. Let's pop over to the next question. Can you use smaller bottles with the tornado toy? Yep, you would be able to use smaller bottles. You've just got to make sure that they do have the opening of a soft drink bottle, okay? So as long as it's got the same size opening as a soft drink bottle, you'll be able to attach this thing onto it, okay? So you can use big soft drink bottles or small soft drink bottles. Just make sure that they've got the same size. Why does the tea bag fly? Fantastic question. Now, when I lit up the tea bag, let's do that one more time so I can sort of explain it as we do it, all right? So let's get the tea bag. Now, as we light up that tea bag, what actually happens is the air inside the tea bag gets a lot hotter as well, okay? And hot air actually becomes what we call less dense, okay? If you guys have ever seen a helium balloon before, you know that it floats up into the air because the helium is less dense. There's less mass for the amount of sort of space it takes up, okay? That's the same with hot air, okay? So when we get our tea bag, let's cut it open again, and I'm going to pour a little bit out. That tea bag, when we light it on fire, it becomes less dense than the air all around us, okay? Let me try and open this one nice and wide. There we go. So when we light it up, it becomes less dense, and as a result, when the fire has gone right down to the bottom, let's try it one more time. Here we go, all the way around. So all of that air inside my tea bag is heating up. It's becoming less dense, and because it's less dense than the air around it, it floats up just like a helium balloon does. And this is exactly how hot air balloons work as well. Now my one here hasn't worked because I've done it in all of the tea that I've spilt down. But you guys saw how it worked before. Alright, next question. Why does the tea bag... Oh, safety... So I should remind you guys one last time, with that tea bag, okay, does involve a lighter or a match, make sure you get your parents to do that, okay? And if they can, pop on a pair of safety glasses as well. They can use their sunglasses as safety glasses. Where are the instructions for making the Teabag rocket? Ooh. Website, okay? On the Street Science website, you'll find instructions on how to make a Teabag rocket. Why did the smoke make rings? Oh, that is a fantastic question. And that has a little bit to do with what we were talking about before with Bernoulli's principle and forces, okay? So if I get my air zucker out one more time and we pull it in and then push it out, there's still a little bit of air in there, then what actually happens is the air particles, they get pushed out and they crash into all the other air particles and they swirl back around, and then they encounter an area of low pressure because there's fast moving air. It swings around and we get some rings. Alright, how do clouds float? One last question. And I've got Science Steve coming in as well. I think he wants to kick me out. He wants to go home. Alright, how do clouds float? That would also be to do with the density, okay? They would be less dense than the air around us, so they float up into the air. Alright. Now, I'm almost done. Science Steve is like, Timo, get out of here. Your time is done. But our virtual classrooms are not finished, okay? We've got one more session. Fingers crossed it's only one more session tomorrow. Hopefully our lockdown finishes, and it's going to be a big one, okay? Because we're going to be exploring, well, I'm not going to be. Science Steve's going to be back. He's going to be exploring solutions, solvents, and solutes. And a sweet Easter science with a gummy bear sacrifice finale, okay? That really excites me. I have never seen this gummy bear sacrifice. Apparently it is too dangerous for anyone else but Science Steve to do. So make sure you guys tune in tomorrow to see the gummy bear sacrifice. Alright everyone, my time's up. I hope you guys have another fantastic day at home, and I hope to see you guys out at some schools, some oshers, and maybe even some birthday parties as well. That's me, Science Tim, signing off. I'll see you guys later.